Hello again, everybody. This is the second part of section 4.2 for calculus class. In the first part, there was a couple of videos talking about the product rule, when we had a function that was made up of two factors, things multiplied together, or different functions multiplied together. This second part of section 4.2 is called the quotient rule. And so what we're looking at is a function. We're trying to find the derivative of a function that is a rational function. It's made up of a function over another function. And a rational function is something specific. It's a polynomial over a polynomial. This is just a case of for any function divided by another function. So a of x over b of x. We're looking for the derivative of that. And unfortunately, it's not as simple as just derivative of the numerator or derivative of the denominator. It doesn't work that way. What we are looking at, if we have a function, f of x, that is made up of two functions, a numerator and denominator, the derivative of that function is all of this. Okay, and there's a little bit of a pattern to it. You take the derivative of the numerator, so this part right here, multiply it by the denominator function. Then you go subtract the numerator function multiplied by the derivative of the denominator. All of that is over the denominator squared. Okay, this is the quotient function. You need to know this pattern. In order for it to work, the derivatives have to exist, and that denominator function, obviously, it can't be 0 because then we'd be dividing by 0. So let's just work through a basic example here. We're looking at function f of x right here in the upper left. We have a linear function over another linear function, so this is a rational function here. And I just put the quotient rule up here just as a reference. So when we go to find the derivative of this, f prime of x, it's going to be that a prime of x is the first thing. That's the derivative of the numerator, 2, times the denominator function, so 4x plus 3, minus the numerator, 2x minus 1, multiplied by the derivative of the denominator, which is 4. All of this is over the denominator squared. All right, so that's the setup. That's applying the pattern, the rule of the quotient rule, the quotient rule. The rule of the quotient was kind of a weird thing to say. It's just applying the rule. The rest of the work is really just simplifying, cleaning things up, distributive property, foiling, combining like terms. Sometimes there might be common factors top and bottom that you could cancel out. Sometimes, but it's just cleaning up from here on out. So, doing some distributive property, we're going to get 8x plus 6 minus some more distributive property. 8x, we're subtracting a negative 4, so that becomes a plus 4 over the denominator squared. So in that numerator, we got an 8x minus 8x. That goes away. 6 plus 4, we are looking at 10 over 4x plus 3 quantity squared. This is our derivative. There's nothing else we can do. There's no common factors or anything to clean up. That's it. And so this is the quotient rule. It's this pattern that's up here in the upper right. Derivative of the top times the bottom, minus the top times the derivative of the bottom, everything over the denominator squared. And so it's just a nice little pattern. You apply that rule, and then you start cleaning up, combining your like terms, foiling, distributive property, all that stuff. And you're going to get functions that look like this. Most of the time it's another fraction, but that's it. So next example, I'm going to do a little bit something more complicated. Please watch.